Okay, here we are in section 4.5, the point slope form of the equation of a line. This is our last version of the equation of the line of a linear equation that we're doing. You'll recall that we've talked about the three different forms: standard, slope-intercept, and point slope form. Standard comes like this: ax plus by is equal to c. Slope-intercept form is y equals mx plus b. And now point slope form is where we'll focus, pardon me, in this section. Y minus y1 is equal to m times, in parentheses, x minus x1. This is the messiest of the two, but it is our fallback plan. So this one is the formal version, all dressed up here. The slope-intercept form, we call this our friend because it gets us instantly to the graph using the intercept and the slope. The intercept is our beginning point, and the slope is how we move to the next point. B for begin, M for move. Point slope form is what I call the fallback plan. When nothing else works, this is usually the equation you want to go with. In other words, you're trying to come up with the equation of the line given some information. They haven't given you anything to work with except for maybe 2 points or a point and a slope. If they give you the y-intercept and a slope, you could just plug those two values in here. But if they give you anything else and you can't see the graph, because from the graph you could do this, or the numbers are unsure, there may be decimals or fractions involved, you would fall back and use the point slope form, where all you need is any point on the line and the slope. Okay. Let's look to see what the pieces of this is, and you've got your xy will always show up. Okay, they'll always remain x and y. And the other letters will be replaced with numbers. So it's the plain x and plain y, they're going to stay there. In the point slope form, the x1, y1 represent a point. Okay, so the a, b, and c are just equal to numbers here in the formal standard form. In the friend form, the m and the b are numbers. In fact, they are our slope and our y-intercept, the y-coordinate of the y-intercept, 0b. Okay, and over here, m, x1, and y1 are numbers, where again, m is the slope, hence the name point slope form, and x1, comma y1 is a point on the line. Okay, any old point on the line. And remember what our goal is. Let's keep that in mind. Our goal is to become experts at graphing linear equations. And by experts, it means we're efficient, we're elegant, we're accurate, and we can go from the graph to the equation and from the equation to the graph. So efficient, elegant, meaning we do it in the most simple way possible. We don't make things harder than they need to be. We're going to be accurate at this, and we can go from the equation to the graph, and we can go backwards from the graph to the equation. And we've had lots of practice from equation to graph, graph to equation when we were working in 4.4 because we had slope-intercept form, and that's our friend because you can look at the equation and create the graph with just plotting a point, connecting it with the movement to the next point. You can look at the graph and identify where it crosses the y-axis and put that number here, and count off the slope, put that number here, and you've got the equation. But sometimes the graph involves variables, or not variables, involves decimals or fractions. They don't cross right at a grid line for that intercept, or you can't count off the slope very easily, or you may not have the picture. Okay, so we want to be able to go, we want to take it to that next level here. When would we need this? So even if the picture, the actual graph itself, is not available, oops, helps if I spell it right, is not available, or it's not obvious. So if you've got fractions or decimals involved, or you don't have the picture at all, we still need to be able to get to the equation of the graph efficiently. And this is what we're going to use, is our fallback plan, the point slope form. So there's nothing new under the sun here. That's a phrase that you might hear in life, and it's really true in mathematics too. We aren't creating mathematics, we're just reapplying the patterns we've already discovered. And so the same is true with point slope form. It's really not a new equation that you have to memorize, because the point slope form is really just a rearrangement of the slope formula, which we learned in 4.3. And hopefully you've been writing it out and saying it every time you used it so far to find slope between 2 points, and now you've got it practically memorized. That's the way to do it. Okay, so here is our slope formula. M is equal to y2 minus y1 over x2 minus x1. And again, the x's and y's were, or the numbers 1s and 2 were indications of first point and second point. Just means second point that we were looking at, and the ones just mean this is the first point we were looking at. Okay. For point slope form, we only care about 1 point. So what we'll do is we will multiply both sides by the x's, specifically that x minus x1. Now, we will be getting rid of, for the point slope form, we need one of the x's and y's to stay visible. So we're going to keep this one visible. We're not going to replace it with numbers. So we're only going to replace 1 point with numbers. So we'll leave the y1 and the x1 there. Again, this is not, what I'm doing right here is not something you have to memorize. It's just, this is a way to recreate point slope form for yourself if you forget it. It's just a rearrangement of the slope formula. So what does that look like? You would multiply both sides by this bottom piece, x minus x sub 1 times x minus x sub 1. And what you'd get is, on the right side, or on the left side here, you'd have x minus x times 1 times m equals y minus y sub 1. The x's would cross each other out because it's the whole thing that you're multiplying by. And you'll notice that's just a rearrangement of the original slope formula, or not slope formula, but yes, it's a rearrangement of slope formula, and now we just flip sides to make it look like our usual point slope form with y on the left. So we switch sides here, and you get y minus y1 is equal to m times x minus x1. I'm just putting that m out front of the distribution. Most of us are just more used to it that way, but that's where you get the point slope form. It's just a rearrangement of slope formula. Okay, it comes in very, very, very handy when all you have is a point and a slope. Any old point. So if all they give you is a point and the slope, you're able to use this formula, because here is your slope and here is your x1, y1 for your point. Any old point on the line and the slope, you're able to put it into this equation, and then what do you do with it? So you would plug in your pieces, then rearrange. What are the pieces? The piece would be m for slope, and your x1, y1 would be the point on the line. Notice here that it's minus the point. It's minus your x-coordinate, minus your y-coordinate. So you would make sure that you plug in for that minus part. Okay, so it'd be the opposite. The point you'd pull out would have opposite signs of what you see in the formula. And then what do you do with it? You would rearrange to get what you want. You plug in your pieces and then rearrange, and so it's like, ta-da! Well, what are we getting excited about? Well, what if you were asked, so if you want, y equals mx plus b, you would then plug in your pieces, slope and a point, into y minus y1 equals m times x minus 1. And then to get it into instant graphing form, you would say you would solve for y. You would take this and solve for y. You would take your point slope form and solve for it. If you want the formal or standard version, okay, then you would plug in your pieces and rearrange, meaning you would move x and y to one side with their coefficient. You don't have to try to solve for x and y, we're just moving those pieces to one side, and you'd take the numbers to the other side. Okay? So that's kind of the background information of point slope form, what it is, where it comes from, how we're going to use it. And when we're going to use it is when all we have is a point and a slope. Or sometimes we might even just have 2 points, and from those 2 points we can come up with the slope, pick a point, use the slope, plug it in, and then decide where we're going to next. So a lot of these problems as we move through this are going to feel like practice plus problems, because you're doing two things. You're finding some information and plugging it into point slope form. Then you're going to rearrange to get what you really want, whether it's standard form or y equals mx plus b or the graph. Okay? Alright, so we'll see you at the bottom of page 1.